Before we write even a single line of code, there's one thing every developer needs is control. Control over our changes, control over our history, and control over how we collaborate. And that's exactly what Git gives us. Git is the system that let us experiment safely, build features in isolation, track every change, and work together without stepping on each other's toes. Whether we are fixing a bug, building a new feature, or working with a global team, Git is the tool that keeps everything organized, traceable, and reliable. Today, we are going to break down Git in the simplest way possible. So, we not only understand how it works, but why it's essential for every developer. Step 1. Let's install Git software from Git guide available in the GitHub website. We click on Git for Windows installer link, which takes us to gitforwindows.org. From here, we click on the download button to start the download. Today, we are installing Git version 2.54. Once the file has finished downloading, we can follow the installation steps to complete the setup. Git is a version control system, which means it keeps tracks of every changes we made to our code. Git has few key components which we need to understand before we proceed. First is repository. It is the entire project and its history. Next, we have working directory. It is the file that we are currently working on. Staging area. It is a waiting room where we prepare changes before we save them. Next, we have commit. It is the snapshot of our project at any point of time. Then we have branches. It is a parallel workspace where different features or different fixes we can install. Remote. It is a shared copy of the repository. Consider it like a GitHub. As we work, Git tracks our changes in 3 steps. First is working directory, where we edit the files. Then comes the staging area, where we mark the changes we want to save, and command to do that is git add. Then comes the commit, is the snapshot of our work, and command to do that is git commit. Each commit is like saving a version of our code that we can always return to. To understand Git branches, let's compare the branches in the Git to the environment we use in the software development. Think of default main branch in Git as our production environment, which is the final stable version of our application that end users rely on. Every other branch we work like the lower environments like development, SIT, and UAT. Dev is where we experiment and build new features. SIT is where we test all the functionalities. UAT is where we give the environment to the users to validate the changes. And finally, production is the polished, approved version. Branches in Git follows the same idea. Let's say we want to develop a new login feature. Instead of touching the main branch, we can create a separate branch, just like working in the dev environment. In the terminal, we type git checkout. Now we are inside our own isolated workspace. This is where we can build safely, test without affecting the main product. This setup let us develop, test, and refine features without risking the stability of the main branch. Once everything is tested and approved, we can merge the dev changes into the main branch. Now that we understand how Git helps us to manage code safely through the branches, environments, and isolated workspace, the next logical question is, where does all this collaboration happens? And this is where GitHub comes into the picture. Git gives us the engine, and GitHub provides the ecosystem around it, a place where team can store the code, review the changes, collaborate, and automate the workflows, and build software together at scale. So the question still remains, what benefit does GitHub provide to its users? GitHub has world's largest developer community. Being an open source accelerates the innovation faster than any internal team can do. Transparency builds trust. GitHub is a standard platform for collaboration and research. AI needs version control, and GitHub handles it very well. GitHub gives us free marketing and massive adoption overnight. Reproducibility is essential in AI. GitHub makes it possible. If we want to build real things, Git and GitHub are non-negotiable. Now we can see the setup is complete. We can verify the installation by opening the terminal and typing git-version. We can see that Git version 2.54 is now installed successfully on our system. Next, let's create a new folder in the drive where we want to keep our project. I have created an empty folder called Git Demo Main folder. Before we continue, let's enable Show Hidden Items in the folder view setting if it's currently turned off. Now, let's open the terminal inside Git Demo Main folder and type git init. This command initializes a new Git repository and create a hidden .git folder inside our main project folder. We can open the .git folder and examine its content to understand what Git actually does and how it actually stores all the parts of the Git in it. Next, let's create a text file called hello.txt using the terminal. But we can also create file manually or copy the existing one into the folder. Let's open the hello file and verify the content before we proceed for the next step. Then go to the terminal and type git add hello.txt. This will stage the changes. Next, we commit the changes by typing git commit -m for messages. We can see that commit has been done on the available branch, which is the master branch. By default, Git uses master branch to store our project history. Now let's open and modify the content of hello file and save the document again and repeat the same steps again. We can also use git status command to check if anything is changed in our project folder before we add and commit new changes to the Git version. To do that, open the terminal and type git status. This will show us that hello file is modified, but changes are not staged for commit. To commit the changes, let's type git add hello.txt, which is staged for the commit, and then we type git commit -m and our commit message. We can see that version 2 of the file has now been added to the Git. We can also check the commit history by typing git log. This shows us all the commits are made in the repository, right from the first commit to all the commits happened after that. Now let's say we want to do some changes to the project, but we're not sure if these changes are going to work for us and will be part of our final project or not. So we create a new branch, call it experiment branch, because we are experimenting new things. To create a new branch, we type git checkout -b experiment. Now we can see that new branch is created in the Git. Now we open and modify the hello file again and save. This time, remember, we are inside the experiment branch. Then we go back to the terminal and add all changes and commit again by typing git add and git commit. We can see that changes are now saved in the experiment branch. Now let's switch back to the master branch by typing git checkout master. Now we are inside the master branch. Now let's try to open the hello file again. We can see that the changes made in the experiment branch are not present in here, which is as expected. This means we have returned to the master branch version of the file. If we want to merge the experiment branch changes into the master branch, we simply type git merge experiments. All the updates from the experiment branch are now merged into the default master branch. We can safely delete the experiment branch by typing git branch -d experiment. We can see that the experiment branch has now been deleted successfully. Finally, when we open our hello file one last time, we can see that the changes in the experiment branch are now available in the master branch version of the file. So to conclude, we learned the core Git workflow, tracking changes, working with the branches, and managing versions effectively. Now let's take things to the next level. We will start by logging into our GitHub account. Under repository tab, we click on new repository button. We are creating a repository named Git demo main folder. And it's important that this name matches to the folder on our computer, so everything stays consistent. We add short description and enable add a readme file option, which automatically creates a readme file into our repository. Then we click on create repository button. Our new public repository is now ready. Next, we return to our local machine inside our Git demo main folder. I have added another text file called hello online for this demonstration. To start fresh, let's delete the hidden .git folder from the main project folder. Now we open the terminal inside the folder and run git init. This initializes a new Git repository. Then we add all files by typing git add and commit the changes by typing git commit. At this point, all our changes are committed. Next, we rename default branch from master to main. GitHub uses main as their default branch name. So this step is essential. To do that is we simply type git branch -m main. Now we connect our local repository to GitHub by adding remote origin. And to do that is we type git remote add origin our GitHub repository URL .git. And finally, we push everything to GitHub by typing git push -u origin main. In this demo, I have used -f flag, which forces the push because our GitHub repository already contained the README file. Now this command will override the online content with our local files. If we check GitHub now, we will see our files uploaded successfully. We can view any file by simply clicking on it. And if we ever need to delete a repository, we simply go to setting, scroll to the bottom and click on delete this repository. We enter the confirmation text and a verification code sent to our email. The repository is then permanently deleted successfully. Whether we are building a simple script or a full stack app or training AI models, this workflow is our foundation. Master it once and it will serve you for your entire career. Thank you and see you in next one.